So this is the fifth lecture, and the interesting part about this lecture is that first it is we'll consider a question that is the inverse of the previous lecture, where we just discussed that vowels will always come together. Now, one of the questions in this lecture is that they never come together. So that's one interesting part. And then another question is, I'll keep the suspense. So let's move on to the next question. So this is the first question that I'm talking about. So this is totally different, but it is a very fun question. We'll find something new in this. So it says that the vowels here only occupy the odd positions. So this may first look very confusing. First, let's write the word. The word is machine. Now it says the vowels always occupy the odd positions. So first, let's write the placeholders, the odd positions. So this is a 7-letter word. I'll just write that in the bracket. So meaning there are 4 odd positions. So I'll write it down here as 1, 3, 5, 7. Meaning your 3 vowels, the vowels are I, A, and E. These are the 3 vowels. So meaning these 3 vowels can only occupy these 4 positions, the odd positions. So the problem is you might be confused. There are 3 vowels, but 4 placeholders or 4 positions. So how we will proceed with this? Now the thing about this question is that you might confuse it with combination. In combinations, what we were doing is that out of a pool of members or out of a pool of people, let's say we were trying to select cricket players or maybe trying to form a committee or a group or a cabinet, something where we try to form groups in real life. So there we had combinations. Out of 5 members, make a committee of 3 members, and these are your restrictions. But the problem is those are people. Like I told you that, some of your friends are making a team. So it doesn't matter what the order is there. But the problem is these are numbers again. We are talking about letters and numbers here. So these are permutations, so the order matters. Like we have been talking about the distinction for a long time. So how will you select in case of permutation? So the idea is pretty similar. All you need to do is that write it like this. 4 select 3. But the thing is that there is no C here, it's P, because we're talking about permutation, not combinations. So the easiest formula, I'll break this down later, I'll explain it later, but the easiest formula that none of the books that I have read from or even AI can explain this in a very intuitive way is that all you need to do is simply multiply 4, which is the total number of odd positions or placeholder you are considering, times 3 factorial. And 3 is your number of vowels. So that's all you need to do. And this becomes 24. Now, 24 is the number that says that your total number of arrangements or permutations when your vowels are at the odd position. But you also need to consider the non-consonants, the consonants or the non-vowels, which in this case is M. So I'll just highlight them with yellow ink. M, C, H, and N. These are your consonants or vowels. And you can see that there are 4 of them. So let me write down in the way that we have been writing these kind of questions. So down here, I can say that the vowels are A, I, E. And then you have your consonants, which is M, C, H, N. You can see that there are 4 of these as well that you need to count in your total number of arrangements. So this is again 4 factorial simply. So this becomes 4 factorial, which is again 24. So then you just need to multiply 24 with 24 because we have considered consonants as well and the number of arrangement that vowels can be counted or arranged when they only occupy the odd positions in the entire word. So all you need to do is 24 times 24, which is again just 24 squared, which is 576. So that's your answer. So this is the easiest way. All you need to do is remember this kind of formula. So I'll erase everything and explain this in the easiest way. So first, let's write down the formula first. So let's say this is your general formula. In this case, we considered out of 4 positions, which is let's say that's your N, and then R is your number of vowels in this case, which are 3 that you are trying to arrange in those odd positions. So this becomes N times R factorial, which we just considered. In this case, it was 4 times 3 factorial, which is again just 24. and then you did your consonants, which you multiplied, which was also 24 times 24. The answer was 576. Let me break this down even further. So what you're really doing is that first let me write the placeholder. And your vowels. So again, you have 4 placeholders, the odd positions, 1, 3, 5, 7, and 3 vowels, A, I, E. Now what you're doing is you're trying to put them in this format. So how many ways you can do that? So let me first write down all the different combinations. So they will be 1, this is one way, 135, and then maybe 137 is another way, and then you have 357, and then you have 157. So remember, we used to do this in combinations, that these are the only 4 ways when you have, because again, what was the combinations formula? This became your combination formula, which is you're selecting 3 members or in some kind of committee, or 3 players out of a pool of 4 players, and you only get 4, these different, because the order didn't matter in combinations, but now here it does. So again, these are your 4 different combinations, but for each one of them, you can see there are 3 different placeholders, or the letters will be placed. So I can arrange A, I, E in 1, 3, 5 format in 6 different ways, because it's 3 letters. So there will be 3 factorial for each one of them, or 6 ways. You can add them all up, 6, 6, 6, and 6, which becomes 24. So this is how you used to get 24 for that number, which I just explained. This becomes 4 times 6, which was just again 24. So you can see in permutations, we have to consider the order. So for each one of these placeholders, there is 6 more ways, because there are 3 letters. So that's why you get 24. But in combinations case, there are only 4, because that we have written down here, because the order doesn't matter. So now let's move on to the next question. Now this is a little bit easier, but the trick here is that the vowels never come together. They're never together. So in the previous lecture, we were talking about they always come together. So now the easiest way to do is that you can first consider that they always come together. So you can simply write down the vowels as one block. There are 2 of them, E and A, and your non-vowels, which are consonants, X, R, T, in a different block. So let's consider they always come together. So we remember that calculation, we have thought about it intuitively. So that will be just one block for the vowel, and 3 letters which are different. So this becomes meaning there are 4 of them. So these 3 letters are treated differently, if you remember, and then there is one vowel block. So this becomes simply 4 factorial, which is again 24. But then for each one of these patterns, since you know there are 2 vowels, they will be arranged in 2 different ways, which are possibly only 2 ways, because 2 letters can only be arranged in 2 ways, EA and AE. So you can just multiply that with this. This becomes 48. Now think about the total number of possible permutations or arrangements that you can make. So let's consider the whole word extra. Now this as in whole, if you consider there are no restrictions, since all the letters are different, this becomes 5 factorial, meaning 120, because simply there are 5 letters and all of them are different. So these are your total number of permutations or arrangements that this word can be arranged in. So 120 different ways. Now you can just subtract 48 from 120 and you get 76, or sorry, 72 is your answer. 72 will be your answer, because again, we considered the vowels when they come together, there are 48 different ways, and we considered the total number of ways. So total minus when they come together is always obviously considering when the vowels never come together. So let me write it down again in an easier way. So number of ways or permutations when the vowels never come together. So number of different ways is total number of ways in which the word can be arranged, which is 120, minus when they come together, when they always come together. Vowels always together, which is, again, we just calculated 48. So your final answer would be simply 72. You can just apply this trick, what you have been doing, and then just subtract it from the total number of ways. This is the easiest way we can do this. So that wraps up lecture 5. We have just one more lecture to cover. Let's see what kind of questions we have in that. But there will be some kind of quiz.